Okay, now today we shall begin with the chapter number 9, ray optics and optical instrument. In the beginning, there are certain definitions which you have already studied in your 10th standard. Okay, and there are certain facts which are given for the better understanding of the chapter. I am just first this write a short note on light. As such, this kind of questions generally is not asked in the examination, but for the sake of understanding, this question is discussed here. Okay, see, the light is it is having nature has endowed the human eye with the sensitivity to detect the electromagnetic waves within a small range of electromagnetic spectrum. Certain part of the electromagnetic spectrum is visible to us. Electromagnetic radiation belonging to this region of the spectrum is having the wavelength of 400 nanometer to 750 nanometer, and this particular range of wavelength is considered for us as light. It is mainly through light and the sense of vision that we know and interpret the world around us. We can interpret, we can see the world because of the sense of light which we are having, or sense of vision which we are having, and the light which is falling on different objects is getting reflected and it enters in our eyes, and our eyes are sensing those reflected light waves, and we can be able to see the objects around us. Okay, now there are 2 points which are two things about light. First is the speed of light in vacuum, and that you know very well. It is about 3 into 10 raised to 8 meter per second. Okay, as you can see, its exact value 2.99, but approximately it is taken to be 3 into 10 raised to 8 meter per second. It is the highest speed attainable in the nature. This is the speed at which the light waves are moving. Light travels in a straight line. Light ray is always traveling in a straight line. That is another point which is about the light rays. Okay, now we talk about the reflection of light, that also you have studied. Okay, see, whenever there is a reflecting object, try to understand reflecting object for us is a mirror. Okay, and if the light rays are falling on the mirror, say for example the mirror is here, this way it is kept. Okay, then the light ray is incident at some angle and perpendicular drawn at a point of incidence. See, this is a point P where the light ray is incident, and the perpendicular drawn at a point of incidence is, say, PM, and this is a incident ray. QP is a incident ray which makes certain angle with the perpendicular. Say this is angle of incidence which is denoted by theta I. Then from experiment it is found that the ray is reflected at the same angle which is equal to the angle of incidence, and this is the reflected ray. This ray is a reflected ray, and this angle of reflection is theta r. The reflected ray makes the same angle with the perpendicular as it is made by the incident ray. So, the angle of incidence, that is theta I, and theta r, that is angle of reflection, both are same. Okay, in this activity, here it is also referred to this. See, this is the plane which is shown, in which there are incident ray and reflected ray. This is the mirror. Okay, this is incident ray which is making an angle theta I, and this is theta r. Okay, and this is the normal drawn at a point of incidence. So theta I is equal to theta r, and it is also found that this ray of incidence, that is incident ray, then this reflected ray, okay, and normal drawn at a point of incidence, they are found to be in one plane. So these are the two rules regarding the reflection, okay. The incident ray, reflected ray, and normal drawn at a point of incidence, they are found to be in same plane, okay. And it is also found that this angle theta I is equal to theta r, that is angle of incidence is equal to angle of reflection. Now you can have the question, what is angle of incidence? The incident ray which makes the angle with the normal, here we can say ABN, angle ABN can be the angle of incidence. And what is angle of reflection? The angle made by the reflected ray with the normal, here it is NBC. The angle NBC is angle of reflection, okay. So ABN is the angle of incidence, and NBC or CBN can be the angle of reflection, okay. Moreover, these laws are valid at each point on any reflecting surface, whether plane or curved. So these rules are applicable to any surface, any reflecting surface, whether this surface is a curved surface or a plane surface. So there are as such three rules, okay. Incident angle and angle of reflection, they are same. The incident ray, reflected ray, and the normal to the reflecting surface at a point of incidence lie in the same plane, and these laws are valid at each point on the reflecting surface, whether the surface is a plane surface or a curved surface. Now we shall talk about the curved mirrors, okay. Mainly there are two types of mirror in general, okay. They are plane mirror and the curved mirror or a spherical mirror. In the spherical mirror there are two types, concave mirror and convex mirror. Now if you have a concave mirror, then its internal surface of spherical mirror is made reflecting, then it is a concave mirror. And if external surface or a convex surface is made reflecting, then it is called the convex mirror. Now if you have a spoon, newly purchased spoon, okay, then this inner part where you fill the food, that behaves as a concave mirror, and this outer part this side which is bulged out, okay, that behaves as a convex mirror, okay. Now there are sign conventions, okay, for the reflection by the spherical mirror and the refraction by the spherical lens. Both the phenomena are having the same sign convention. Now first of all, you try to understand this part, okay. How do you show the mirrors? Say for example, if you want to show the concave mirror, then its inner surface is made reflecting, so this way you are showing the concave mirror, okay. And if the outer surface is made reflecting, then this is the convex mirror, okay. So this is the way you are showing the two mirrors. This is convex mirror and this is the concave mirror, okay. Now the different parts of the mirror, first of all we shall understand that which are the parts of this mirror, and then we shall discuss the sign conventions, okay. The first thing is radius of curvature. Okay, the first thing that we are going to discuss is the radius of curvature. Now try to understand. The mirror is made from a spherical shell. You consider a hollow spherical shell. Shell means a hollow part. Okay. Now, if you consider the hollow spherical shell, then this is the hollow spherical shell, and if you cut this hollow spherical shell from somewhere here, okay, if you just cut the surface, cut the hollow spherical shell, then this part which you are getting here on your right hand side, this part is a circular part and which is having a spoon like structure. Say for example, inside surface is made reflecting, inside surface is made reflecting, then this will behave as a concave mirror. Now radius of curvature. Now try to understand. First of all, we talk about the center of curvature. Now this is the spherical shell which is having its center here somewhere at this point. Say this point is C. The center of the spherical shell from which the mirror is cut or mirror is made, that center, this point C, is called the center of curvature of this mirror which we have made. Now this part as such is not needed. This part is now taken out. Okay, this is now no more. Okay, so just we are removing it. Okay, so now you are having a proper, say, concave mirror. Okay, so now you can understand that center of the spherical shell from which the mirror is cut is known as the center of curvature of this mirror. Now the radius of the spherical shell, now try to understand C to this point, or say the part which we have removed, okay, that was having the radius up to this. So this radius of the spherical shell from which the mirror is made is called the radius of curvature, and it is always denoted by capital R. Okay. Now there is a pole, the center of the mirror. Try to understand, the center of the mirror is known as the pole. The center of the reflecting surface of the mirror is called the pole. So here this will be the center and this is considered to be the pole of the mirror. Okay, now you have two types of mirror. Okay, this is what about the concave mirror. If the reflecting surface is bulged out, or we can say the outside surface, if you turn out that mirror, say for example this is the reflecting surface. Now if you made this as the outer surface as a reflecting surface, then this will behave or this will become the convex mirror, and for it the center of curvature will be this side. If you complete this particular sphere, then this will be the center of the sphere and the center of curvature will be on its right. Okay, and the radius of curvature is the same, that is radius of the spherical shell from which the mirror is made, that is called the radius of curvature of the spherical mirror, or rather it is same for convex and concave mirror. Okay, now there is another definition, that is principal axis, the imaginary line which is passing from the center of curvature and the pole. Now you can understand this part. Okay, we have this as a pole. Okay, and this is center of curvature, and from this one imaginary line is passing. This is called the principal axis. Okay, now there is another definition, that is principal focus. Now principal focus is the point where the rays parallel to the principal axis meet or appear to meet after reflection, that is called the principal focus. Now try to understand, we have parallel rays which are falling on this mirror. Say for example, this is your principal axis, okay. Now rays parallel to principal axis are incident on this concave mirror, and after reflection they are passing through one common point, that is the F. Okay, so this is the point from which the rays after reflection from the say concave mirror, right now concave mirror, are passing, then this is called the focus of the concave mirror. Now what will happen to the convex mirror? Now the rays which are parallel to the principal axis, which are incident on this convex mirror, okay, what will happen to them? They are as such going away from each other, you can see. They will not meet here on left hand side. And now if we extend these rays in the backward direction, then they appear to meet at this point. Okay, they are not actually meeting, they are appearing to meet. Okay, so this point is called the principal focus of convex mirror. So either they actually meet or they appear to meet, both the points. For concave they actually meet, for convex they appear to meet. These points are known as foci. Focus no plural છે, foci for both the mirrors. Okay, now the next definition, if it is there, yes, it is paraxial rays. Okay, paraxial rays are the rays which are close to the principal axis. They are called the paraxial rays. Then there is a definition of focal plane. A plane which is passing through the principal focus and normal to the principal axis is called the focal plane. You can see the focal plane here. Okay, it is passing through the principal focus. Okay, so this plane, imaginary plane, it is passing through the principal focus and it is perpendicular to the principal axis. This is called the focal plane. So these are certain basic definitions that you must have studied in your 10th standard even. So try to go through it, okay, and try to understand the different parts of the mirror, okay.